So here is another question on simple harmonic motion. So it is given that a particle executing SHM along a straight line, it has a velocity of 4 meters per second. When its displacement from mean position is 3 meters. So for displacement from mean position 3 meters, it has a velocity of 4 meters per second, and 3 meter per second when its displacement is 4 meter. Okay, find the time taken to travel 2.5 meters from the positive extremity of its oscillation. So let us write the different points. First and most importantly, write the SHM equation. Okay, sine omega t plus phi. Now here this question is in relation to displacement from mean position, that is y, and velocity. So an equation which relates these two, we have already derived it in the previous question. It is velocity v is equal to omega into a square minus y square. On squaring both sides, we get v square is equal to omega square into a square minus y square. This is very important in the context of this question. So here, according to the data which is given in the question, v is equal to 4 meter per second. The velocity is 4 meter per second when displacement from mean position is 3 meters, and v is equal to 3 meter per second when displacement from mean position is 4 meters. So when we put these two values in this equation, we get 4 square is equal to omega square into a square minus 3 square. That implies 16 is equal to omega square into a square minus 9. This is equation 1. And another thing is 3 square is equal to omega square into a square minus 4 square. That implies 9 is equal to omega square into a square minus 16. That is equation number 2. Okay, so if we divide equation 1 by equation 2, we get 16 by 9 is equal to omega square into a square minus 9 by omega square into a square minus 16. Omega square gets cancelled. So we have a square minus 9 by a square minus 16. That implies on cross multiplication 16 into a square minus 16 is equal to 9 into a square minus 9. That implies 16 a square minus 16 into 16 is 256, yes, is equal to 9 a square minus 81. That implies 16 a square minus 9 a square is equal to 256 minus 81. That implies 7 a square is equal to it is 175. That implies a square is equal to 175 by 7. 175 by 7, that is coming 7, 14, 2, 25. So that implies A is equal to plus minus 5 meters. This is the maximum displacement on either side of the mean position, that is A. Then it has been asked that find the time taken to travel 2.5 meter from the positive extremity of this oscillation. So let us try to understand the situation. So it has been, we have determined here A is equal to 5 meter. So if this is the SHM motion, this is the mean position, then this is 5 meter A, and this here also 5 meter, this is A. This is the mean equilibrium position. Here another thing which we have to find out is the angular frequency. So we can put this A value here in any of these things, that is 16 is equal to omega square into a square minus 1. So here if we put this value here in this equation, 16 is equal to omega square into 5 square minus 9. That implies 16 is equal to omega square into 25 minus 9. 25 minus 9 is equal to 16, implies omega square is equal to 16 by 16, so it is 1. Okay, so it is equal to 1. Omega is equal to 1 radian per second. Okay, this. So here it is, we have got the value of omega. Okay, so now we have got the value of omega. Omega is equal to 1 radian per second. A is equal to 5 meters, omega is equal to 1 radian per second. This is the positive extremity of oscillation on the extreme right. At this position there will be an initial phase angle, because this is the starting point we are considering. From this point, how much time it will take to move 2.5 meters? That is almost halfway to this point. So counting starts here, observation starts here. So there will be an initial phase. So here will be, if we put these values, at this position y is equal to 5. So 5 is equal to a sine omega t. 5 sine t plus phi, sine t plus phi, it will be here like this. Okay, that implies sine 0 at t equals to 0, it becomes only sine phi at t equals to 0. Okay, at beginning of the time. So sine phi is equal to 5 by 5, which is equal to 1. That implies phi is equal to sine inverse of 1, which is equal to pi by 2 radian. So the initial phase angle is equal to pi by 2 radian. So the SHM equation is like this: y is equal to 5 sine t plus pi by 2. Because omega is equal to 1, sine t plus pi by 2, that is equal to 5 cos t. 5 cos t. Now from this equation, from this point, we have to determine how much time it takes to reach this position here, which is y is equal to 2.5 meters. So again we'll put this value here, that implies 2.5 is equal to 5 cos t. That implies 2.5 by 5 is equal to cos t. That implies cos t is equal to 1 by 2. We have to express this in terms of cost to equate these two functions. So it will be cos 60 degree, that is cos how much? Pi by 3. Pi by 3, yes, pi by 3. That implies t is equal to pi by 3 seconds, which is equal to 3.14 by 3, which is equal to, it is coming around 1.047 seconds. So t is equal to 1.047 seconds. So from this position on the extreme right, it will take 1.047 seconds to reach 2.5 meter at this point from the positive extreme right. Okay, this is 1.047 seconds. So first we had to determine the SHM equation. Okay, we got the different values. First the value of A, then we got the value of omega, then considering the condition in the question, that is from the positive extreme right, how much time it will take. So for the positive extreme right position, we wrote the SHM equation considering the initial phase angle for the particle to be in this position, and we got this equation. Then from this position it will move 2.5 meters. So we put this condition here and we got how much time it will take. Okay, so this is the thing.